Okay, guys. Now, what if we've got a combination of parallel and series capacitances together? Basically, what we need to do is we need to reduce this entire circuit, which has 30 volts, a 4 farad capacitor here, a 3 farad here, and a 6 farad down to a single capacitor. Now we're going to start out setting up our chart like we did before, CQV. You can put them in any order you'd like. And we're going to put here 1, 2, 3 total. I'm going to leave a little space down below because we're going to be adding stuff on the bottom of this particular chart. There we go. We're all set. So now I've got to get this down to a single capacitor, and I can't do this all in one shot. So I need to look for what I call the deepest part of the circuit. I'm looking for a parallel or a series circuit inside of that circuit that I can reduce to a single capacitor. Now that means that if it's series, there's no splitting going on anywhere within everything's all in one line, and that's what we have over here. If you look at C2 and C3, they are in series with each other, and there's no branching points or anything like that. So we're going to reduce C2 and C3 down to a single capacitor. I'm going to go to my chart, and I'm going to write 2, 3 down here on the bottom. Now we're also going to fill in everything we know. C1 is going to be 4 farads. C2 is going to be 3 farads. C3 is going to be 6 farads. And we know the total potential across this is going to be 30 volts. So we're going to reduce this thing, and I'm going to draw it this time so that I'm going to have a circuit that's going to look like this. Now there. All right. Now this guy over here is going to be 30 volts. This is going to be my C1, 4 farads. And this is going to be my C2-3 in combination with each other. So let's figure out what that actually turns out to be. Well, if C2-3 are in series, remember in capacitors, series reciprocals add up. It's the opposite of resistors. 1 over C2-3 is equal to 1 over C2 plus 1 over C3. That's going to be equal to 1 over 3 farads plus 1 over 6 farads, which turns out to be 1 over 2. Take that reciprocal. C2-3 is going to be a 2 farad capacitor. I log it here, and I come down here. I log it here. There's a 2 farad capacitor. Now we want to take this and reduce it down to a single. Let's see if I jam it in here. There we go. A single capacitor. That's my total capacitance. There's still going to be 30 volts across this thing. But I want to find out what's going to be my total capacitance. Well, now I've got C2, 3, and C1 in series with each other, which means to find my total capacitance, that's C1 plus C2, 3, which is going to be equal to 4 farads plus 2 farads, which is going to wind up giving me a 6 farad capacitor for the whole entire thing. Now we're all set. We can start solving for what our charges are across each other. Well, let's deal with first the total. We happen to know that C total, I'm going to jot this right up here. This guy is a 6 farad capacitor. So I know my voltage, I know my capacitance, I know that Q is equal to C times V, and we're going to make these all total. which is going to be equal to, I've got a 6 farad capacitor. I've got 30 volts across this. So that's going to turn out to be 180 coulombs. All right. Now the next question is, what is the same? And what's the same in capacitance as far as going backwards one step here? Since these are in parallel, I know that the voltage total is going to be equal to my voltage across 1, my potential across 1, is going to be equal to my voltage across 2, 3 as a single unit. And they're all going to be 30 volts. So let's put that on there. Got 30 volts there. And that's across 2, 3. And I've got 30 volts across here. Well, now, all of a sudden, it's simple to figure out what the charges are in each of these. Q1 is C1 V1, which is going to be equal to 4 farads times 30 volts, or there'll be 120 coulombs across that particular capacitor. Now, I'll deal with 2, 3. Q2, 3 is going to be equal to C23 times V23, which is going to be equal to, well, I got 2 farads, and I've got 30 volts across there, and so that's going to wind up giving me 60 coulombs. That works out pretty nicely because these two add up to my total, which was 180. Now let's step backwards. We know that C23 represents C2 and C3 in series with each other. And in series, we know that, well, we know the charges are all going to be the same. So that means that Q23 is going to be equal to the Q across 2, is going to be equal to the Q across 3. They're all going to be 60 coulombs. So I can fill that right in here. 60 coulombs, 60 coulombs. Now we're all set. Now we can solve for my voltage. I'll do it down here. We know that V is equal to Q over C. Whoops. Q over C. And we'll do it for 2. And we know Q2 is going to be 60 coulombs. We know that C2 is going to be 3 farads. So that means I'm going to get 20 volts across that one. Let's do it for the other guy. For V3, that's going to equal to Q3 over C3. That's going to be equal to 60 coulombs. Over, in this case, it's going to be 6 farads. And that's going to be 10 volts, which works out beautifully because they're going to add up to 30, which is exactly what we should have across that leg of the capacitor. All right, everybody. Well, as you can see on the top here, we have got a combination parallel series circuit. You've got 6 farads, 6 farads, 6 farads, a 4 farad right here, 2 more 6 farads, another 4 farad, another 6, and another 6. And what we want to do is we want to reduce this down to a single capacitor and then solve from there going forward to do to find what the voltages and what the potentials and the currents are across each one of these. I'm going to ask you to solve this on your own first, and then we're going to take you through the whole process. Okay? Pause it right now. Try it yourselves. If you can't do it, then continue onwards and you'll get some hints how to do this. All right, at this point, I assume that you've either done it or you've had some problems along the way doing it. So let's take a look. Now, as before, we needed to find a parallel or a series circuit within these that we can use to solve. Now, if you take a look at this, these last three are in series, and there's no parallels inside them. Some people want to start going C6 and C8, but you can't because C8's in series with these guys, so you can't take those two in parallel. It's got to be an isolated series or an isolated parallel. So what we're going to do is we'll work our way forward. Yes, the chart's all filled in, but that's all right. You'll see how it gets filled in as we go along. Right now, none of this stuff would be at the bottom here. So first thing I do is C6, C7, 8, 9. They're all in series, so the reciprocals add up. That's 1 over 6 plus 1 over 6 plus 1 over 6, which means that has an equivalent capacitance of 2 farads. So I wrote 7, 8, 9 here, and 2 farads. Don't worry about the stuff to the right. We'll get to that in a minute. All right, now that we've got this, and we've made a whole new circuit, I didn't write in the stuff that we're not dealing with as of yet. Right now, the next thing we want to do is we want to solve the next series or parallel that's totally isolated. Well, the only thing that's isolated is over here at the end. You've got these two guys, C6 and C7, 8, 9, in parallel with each other. And in parallel, capacitances simply add up. So you can see I've got 6, 7, 8, 9 here. And C6 plus C7, 8, 9 gives you 6 farads when you add up the 2 and the 4. So I wrote that right in over here, and we're ready to go. We've just reduced these guys down to a single capacitor, which I'm going to put right here. Now, up on the top here, there is C6, 7, 8, 9 that we just calculated before. This one capacitor right there. That now is in series with these. That came from the parallel from before, so it's all in series. I've got 6, 6, and 6. So 1 over C, 4, 5, 6, 7, 8, 9 equals 1 over C4 plus 1 over C5 plus 1 over C, 6, 7, 8, 9, which is exactly like what we had when we just solved for 7, 8, 9. It's all reciprocals of 6s. 1 over 6 plus 1 over 6 plus 1 over 6 gives us a 2 farad capacitor. So I come over here, move that out of the way. I've got 4, 5, 6, 7, 8, 9. I write in 2 farads for that. And I redraw my circuit again down here. So now I've got over here, let me just fold this over so that you guys can see everything. There we go. Now, there's what we just solved for. C4, 5, 6, 7, 8, 9, the 2 farad capacitor, which is in parallel with the 4 farads. We know that they add up. So I come on my chart. I've got 3, 4, 5, 6, 7, 8, 9. And it's going to be C3 plus C4, 5, 6, 7, 8, 9. And they just add together. 2 plus 4 gives me 6 farads. Bam, right there in the chart. Now we've reduced these two down to a single capacitor. C1 plus C4, 5, 6, 7, 8, 9 plus C2. And these guys are all in parallel, so they're reciprocals. C total equals C1 plus C2 plus C... 1 over C1 plus 1 over C2 plus 1 over C3, 4, 5, 6, 7, 8, 9. It's equal to all the 1 over 6's together. So the whole thing turns out to be a 2 farad capacitor. And that's right there in the totals. Now what we're going to do is we've got that done. We're going to start to move our way forward. Let's figure out what all the voltages and the currents are. First thing, let's solve for the completely simplified circuit. We've got it down to a single capacitor. Let's find my total charge on here. It's a 2 farad capacitor, all in total. We've got 120 volts, of course. Q equals CV. I've got 120 volts times 2 farads. That gives me 240 coulombs across the entire circuit. So, under total, I wrote in my 120 volts, which is what I'm going to make this voltage equal to. Should have jotted that in there. Okay. And that gives me 240 coulombs in there. Now we're going to step forward. C total actually represented C1 plus C3, 4, 5, 6, 7, 8, 9 plus C3 all in series. Right? Because we combine these to get the total. Now we know in series, charges are all going to be the same. So if there's 240 coulombs across C total, there's 240 across C1, across C3, 4, 5, 6, 7, 8, 9 in combination, and across C3. So they're all 240 coulombs. I can find my voltage pretty easily. V equals Q over C. I'm doing it for C1, but it's going to be the same for all these because they all have identical capacitances. Now, if they weren't identical, I'd have to do each one separately. But it works out pretty easy. V equals Q over C. 240 coulombs over 6 farads gives me 40 volts. And that's for all these guys. So I come back over to my chart here. For C1, I wrote 40 volts in. This is actually C2 down here on the bottom. Oops, sorry about that. C2. Same thing. And C3, 4, 5, 6, 7, 8. Right over there. Now we can take care of, we've already filled those all in. Now remember, 3, 4, 5, 6, 7, 8, okay, really was C3 and C4, 5, 6, 7, 8 in parallel, right? C3 and C4, 5, 6, 7, 8 are in parallel. So V3 equals V, 4, 5, 6, 7, 8, which is equal to 40 volts. All right. Now we can find out, since they in parallel, things have the same voltage, we can now figure out what the charge is. C equals QV. For C3, it's 4 farads times 40 volts equals 160 coulombs. For Q, 4, 5, 6, 7, 8, 9 equals C, 4, 5, 6, 7, 8, 9. And V, 4, 5, 6, 7, 8, 9. I just wrote a scribble in there, but they're both 4, 5, 6, 7, 8, 9. Is going to be equal to 2 farads times 40 volts equals 80 coulombs. Works out nice because those two add up to 240, which is exactly what should happen. Go to my chart. I start filling that in. This guy is going to be 40 volts. Get 160 coulombs across there. And then, of course, 40 volts. And I get 80 coulombs across there. Now let's take that C4, 5, 6, 7, 8, 9 and break it up into C4, C6, 7, 8, 9, and C5 all in series with each other. I'm not going to be able to fit that under there, so let me just fold it over and get that to fit. All right, pull that out. There we go. All right. Now, here we go. C4, C6, 7, 8, 9, and C5 all in series with each other. In series, charges are the same. Since we knew C4, 5, 6, 7, 8, 9 as a combination had 80 coulombs across it, it's right over there on the chart, we know that C4, C6, 7, 8, 9, and C5 all have 80 coulombs across them. In series, the charges always are the same. So, there we go. So, all laid out there, C4, 5, 6, 7, 8, 9, 4, Q5, Q6, 7, 8, 9, all 80 coulombs, and we filled that into the chart. 80 coulombs for 4, 80 coulombs for 5, and, of course, 80 coulombs for 4, 5, 6, 7, 8, and 9. We can now find the potential across each of these, find the voltage. V equals Q over C. I've got 80 coulombs over 6 farads. That's for 4, but it's going to wind up being the same because they're all identical capacitances. Gives me 13.3 volts across each of these. So, across 4, I write 13.3 volts in. Across 5, 13.3 volts. And, of course, across 6, 7, 8, 9, 13.3 volts. Now let's back it up a little further. Now we've got 5. Well, step 5, which represents C6 and C7, 8, 9 are in parallel with each other. Since they're in parallel with each other, we know the voltage is the same. E6, 7, 8, 9 as a combination at 13.3 volts across it. Then C6 and C7, 8, 9 both have 13.3 volts across it. C6, 13.3 volts. C7, 8, 9 has 13.3 volts, excuse me. So now that we know that, we know the capacitances, we can find the charge on each of these. C6, Q6 equals C6 times V6. I've got 4 farads, 13.3 volts across it, 53.2 coulombs. And there's going to be some rounding going on in here. C789 is going to be, Q789 is C789 times V789, which is 2 farads times 13.3 volts, gives me 26.6 coulombs. So when we go to the chart and we fill that right in. And remember to pause as you're going through this thing, because I'm going quickly, but you guys can stop as we're going along. Let's get the 789. There it is. 13.3 volts, 26.6 coulombs. Now we go back, we go to the final step, which is going to be right here. C789 represents C7, 8, and 9 all in series with each other. Once again, series, we know charges are the same. So Q for 7, Q for 8, Q for 9 is equal to Q789, which is 26.6 coulombs. And we filled those in the chart already. Now it's easy to find the voltage. V equals Q over C. You've got your voltage, 26.6 coulombs, 6 farads, 4.43 volts across each of them. And they're all identical. And that's not because in series they're going to be identical, but because they're all identical capacitors, they're all going to be equal. It's all laid out there, and that's the whole thing. All right, guys, give it a shot on your own. I'll be putting some problems up for you to try out, and I'll be putting solutions on it. See you later. Bye.